Okay, now that we've had a quick look at quadratics in standard form and the different parts that go along with graphing them, let's go ahead and take a look at an example, and then we'll try one on our own. You can see here we have f of x equals 2x squared minus 8x plus 6. And so the very first thing that we have to verify is that it's written in standard form and that we can identify the a, b, and c parts. Now, just by looking at it, we can have a pretty good visual idea of what this should look like. We know that the a value or the leading coefficient is greater than 1 or greater than 0, excuse me. So that tells us that it opens up. But that 2 also, if you remember, lets us know that it's a little bit steeper than your standard quadratic. And so, you're probably going to be able to tell just, that it's probably going to be a little steeper. It's going to be opening up like that. And so that'll give you a good sense of what the final answer should look like. Now, we need a starting place. And if you recall from linear functions, our starting place was always the y-intercept. We wanted to find where it crossed the y-axis and work off of that point. In quadratics, what our starting point is the vertex. And if you recall, the vertex lies on the axis of symmetry. And so if we can find our vertex, then we can work around that point, and we can also work around the axis of symmetry. And so if you recall, we have this formula, x equals negative b over 2a. And if you take your a, b parts and plug that in, you're going to see x is equal to 2. Now, keep in mind that this is the axis of symmetry, x equals to 2, so that is a line, a vertical line that we can plot, and the x-coordinate for the vertex is also equal to 2. Now, we just need to evaluate this function for 2 to find the y value for the vertex, and you can see we come up with negative 2 as our vertex. So we simply need to start off by drawing our vertex and our axis of symmetry. And so if I look at this sample down here, I would start off by simply just drawing that axis of symmetry. And keep in mind, that's not part of the actual graph. It's just a visual aid to help us see the symmetry. And then I'm going to plot the vertex itself. Now, the one thing about graphing quadratics is, 2 or 3 points is sometimes not enough. What I'm going to recommend to you is that you should get the vertex and then 2 points on the right side of the vertex or axis of symmetry, and then the symmetrical points on the other side of the axis of symmetry. So it doesn't matter which side you elect to get the 2 points off of, but what I'm going to suggest to you is that you just simply do a little t-chart action and pick 2 points on either side, or 2 x values on either side that would be relatively easy to find a value for. And so in this case, I'm going to use 0 and 1. And if I evaluate 0 and 1, I simply get 6 and 0 as my points. And you can see here that I have 2 points on that side. Now, from here, you don't have to evaluate anymore. This is where you're going to use your knowledge of symmetry to help you with the additional points. So since this is just 1 unit away from the axis of symmetry, my symmetrical point will be 1 unit away on the other side. Same thing here. This one is 2 away on the axis of symmetry, so I'm going to go 2 on that side. And now I have just enough points to sketch my quadratic as best I can. So make sure that you label all your points, or give me a table. That is very important, especially whenever we're drawing quadratics and we're not able to be as precise as we are with lines. So make sure that you do that. So let's look at the next one. Hopefully you've taken the opportunity to do these 2 problems by yourself already. I'm going to go ahead and work through these quickly. Be sure to stop the video if you need to look back at something and you are unsure. So first things first, I'm going to identify the a, b, and c. So I know here a equals negative 1, b equals to 2, and c equals to negative 2. Now this is a good visual. The negative 1 lets me know that it's going to be upside down. And I want to identify my axis of symmetry to start. And so I'm going to say x equals negative b. So negative 2 over 2a. So that's 2 times negative 1, which is going to give me negative 2 over negative 2 equaling to 1. So my axis of symmetry, x equals to 1. And I can simply take some little visual aid. You can either do a little highlighter function on the computer, or you can do just like a little dotted line, vertical line, just to kind of give you some guidance. Now, the next thing I'm going to do is I'm going to find my vertex. I need the point for my y value, and if I just plug 1 in and each of the x values, f of 1 equals to -1, so that gives me a vertex of 1, -1, and so you can see here that I have a vertex. Now, remember, I had a negative, and so I know that this thing's going to go down for me. And so now what you need to do, and this is where you want to use your calculator effectively, just t-chart a couple points. And so here, I'm going to t-chart a 0 and a -1. You could choose the 2 and 3, but what I'm definitely going to recommend is you pick one side or the other. And so here we have 0 gives us -2, and this gives us -5. So 0 to -2 and -1, -5. And then I want to find the symmetrical points on the other side of the axis of symmetry, and then I just do the best job I can to sketch that. Okay, and so that's how you graph a quadratic in standard form. Alright, and then for this last one, I'm just going to go ahead and quickly do this. You can check your work against mine after I finish doing this. Okay, you can see here all of the work that I've done for part B. Now let me point out a few things here for you. You can check your work against mine. First of all, I got my A, my B, and my C values. Now, I should notice immediately a couple things about my standard form here. The A value, the leading coefficient, is 1/2. And in this particular case, the 1/2, if you recall, kind of opens that thing up a little bit. It makes it a little bit flatter. If you recall from our translations and transformations in prior units. And it is also going to open it up a little bit more. So if we go ahead and work here, we can find the x value for the vertex and the axis of symmetry, and then we can find the vertex. Now the first thing about the vertex you'll notice is we got a fractional component here. You can write that as a decimal or as a fraction, whatever makes it easier for you to graph. And also, please just estimate the 1/2, the 1.5 as best you can, and work off of that. Now, notice that when I plotted 0 and -1 for my x value, I didn't get a real clear-cut picture. And so what I did is I added a third point or a third x value to plot just so that I would get a better view. Now you're going to have to make these decisions on your own. This is our first two examples of graphing quadratics in standard form. The next set of examples are going to use these skills, but not necessarily to graph. For this particular problem, it didn't ask us to graph it specifically, but we can use a lot of our graphing skills that we learned graphing quadratic functions to answer the question. Now, it says find the minimum and maximum value of each function. Now, if you recall, the minimum and maximum is just the vertex, depending on whether it's up or opening up or down. And then, of course, we need to state the domain and state the range. So if we look at this, f of x equals x squared minus 2x plus 1. We have a leading coefficient that is a positive value. It's greater than 0. And so that's let us know that this parabola is going to open up. So we're going to be actually looking for a minimum. So our vertex is going to be down at the bottom. And so we're going to do that by simply finding the x value for the vertex first. So that's negative b, which in this case is a -2, so we have to do negative -2, and then 2 times a, and so that's going to equal 2 over 2, which equals to 1. Now I know we've had a number of examples where x equals to 1. Don't get the idea that every single problem the x value is going to equal to 1. And then we want to find the y value for that. And so remember, whenever you evaluate any function, please use parentheses, and then we have 0. So we actually have a vertex of 1, 0, and so that's 1, 0. So we can say our vertex of 1, 0 gives us a minimum value. The second part of this question asks us to state the domain and range. Now, the domain should be very easy, and let me just work on that one first. If you look at the domain, if we took all the x values out to positive infinity, this thing would still be getting wider and wider to the positive side, so it's going to go on forever that way. Same thing to the left. If you took this to negative infinity for all the x values, it's just going to get wider and wider. So the domain for all quadratics is always all real numbers. Just like linear functions, the domain is always all real numbers. However, the range is slightly different. The range is going to be whatever the minimum or maximum value is, and then it's either going to go to positive infinity or negative infinity depending on whether it opens up or down. And so you can see in this case our y value, and if you keep in mind we're talking about all of the y values and for our range, and so our y value starts at 0 and it goes up to a positive infinity. Now if you remember interval notation, it's equal to the 0, so we have a closed bracket, and of course we're not going to be equal to infinity. That's interval notation. You could also write this just as a simple set notation if you chose to do it this way. So you could say it's all y values such that y is greater than or equal to 0, and that would work just as well. So either way that you write that is going to be perfectly fine. Let's look at the second part here, part B. And so we have negative 5x squared plus 15x minus 3. And so if you look at this, we have a leading coefficient that is a negative value, so we know that that's going to go down, leaving us a vertex that's at the top of the graph. Now this one's going to be a little bit more challenging, so we're going to have to use our calculator a little bit better. Same process here though. We're going to go solve for the x value, which is going to give us negative 15 over negative 10, which is basically going to reduce to 3/2, and of course you can write that as 1.5. Either way come out to be the same for your y value. And so if I plug this in, and this is where you definitely want to use your calculator a little bit more efficiently, so that's going to give us 33 over 4, which is the same thing as 8.25. So if you wanted to go ahead and write it like that, if you wanted to write that it has a maximum value 1.5, 8.25, that's perfectly acceptable. 3/2 and 33/4 is also a correct answer. And so if we look at the domain value, if you remember, domain of quadratics is always all real numbers, and the range in this case is going to be the highest point, or it's going to go from negative infinity, and it's going to go all the way up to a y value of 8.25, and of course it'll equal that 8.25.